Factorising is really important when we're looking at simplifying, because it allows us to take out a common factor from an addition, addition or a subtraction, and then with that common factor we can simplify above and below, the denominator and numerator. Well, let's go right back. What are factors? Well, factors are numbers we can divide two terms by. So if we think about the factors of 10 and 30, because that's something we've come across a lot, what are some of the factors of 10 and 30? So it has to be a factor of both numbers, because the factors of 30 are 1, 3, 2, 5, 6, 15, 30, there's heaps of factors, correct? But not all of those are factors for 10. So which ones are factors for both 30 and for 10? Which ones can we divide both 30 and 10 by? Can we divide both 30 and 10 by 1? Yes. So 1 is a factor. Can we divide both 30 and 10 by 2?
Yes.
So 2 is a factor. Can we divide both 30 and 10 by 3?
No.
So 3 is not a factor. Can we divide both 30 and 10 by 5?
No.
Yes.
So 5 is a factor. Can we divide both 30 and 10 by 6?
No.
10?
Yes.
Yes.
And anything more than 10 is not going to work. Why?
Because 10 is the lowest number.
10's what?
10 is the biggest value you're possibly going to be able to get. You can't divide 10 by something and get more than 10. So, not the value anyway. So factorising is where we take, so this is what factors are. Factorising is when we take out the common factor at the front of an expression. Think of it like the opposite of expanding. And that's a good way to check whether we factorise correctly. So I see a lot of you asking how I factorise correctly. How can we check that? Well, if we expand it, what should it look like? What we started with, correct? So we went through this one earlier. We had 4x plus 2. Jake said, well, 2 is the common factor. So we divided 4x by 2 and we got 2x. We divided the 2 by 2 and we got 1. If I wanted to check that, I could expand this. And what should I see? What's 2 times 2x? 4x plus 2 times 1. So have I done it correctly?
Yes.
Very good. Now I'm not going to write that on the board because we'll get confusing. But factorising is like the opposite of expanding. Try and think of it like that. So if I look at my next example, I ask, what can I divide both of these terms by? What can I divide both 16x squared and 2x to the power of 4 by? 2. So I start with 2. Do you want to do it in a number of steps or just one step? One step, okay, we must be pretty confident. So, yes, I can do the numbers by 2, both of those divide by 2. That's going to be the highest common factor. How do you know? 2. You've got 2 in both your factor and your number at the front, so you know you're all good. What else can I divide both of these terms by?
Yes.
X? Just x to the power of 1? X to the power of 2. So what's 16x squared divided by 2x squared? 8. And what is 2x to the power of 4 divided by 2x squared? Plus x squared. Very good. We've just factorised that expression. For the last one, what's different? So negative values. Okay, interesting. See how it affects our factorising. What's a common factor for both 32a or negative 32a squared and negative 16a? 16. What else? A. So what should I write in here? Negative what? Negative what? 2. A. Am I done? Minus? Minus 1? Okay. Now I could actually factorise that further. Who thinks they can see a way I can factorise that further? Not you? What if I divided both terms by negative 1? Could I do that? Does it make it easier? Is this easier to look at? Or is the top one easier to look at? All I've done is take the negative 1 on the outside, correct? Divided both terms by negative 1. Does that make sense? So factorising isn't anything new, but it's a skill that we need to be able to nail.
Does it matter which side the negative one?
It has to be before the value, yeah.